I want to show you one of the most important and also one of the most highly debated fossils in all of human evolution. Here it is, Dragon Man. There's something so captivating about the big square eye sockets, the enormous brow ridges, the really flat head. It's obviously human, recognizably human, and yet there's something so different about it, isn't there? It's truly a window into humanity's distant past, no doubt about it. It was given the nickname Dragon Man because it was found here in the Chinese city of Harbin, close to this railway bridge, I think, as long as I'm using this Chinese website correctly. Harbin is in the province of Heilongjiang, which means Black Dragon River, hence Dragon Man. Very cool name if you ask me, very cool. Apparently, a worker building that railway bridge discovered the skull in 1933 during the Japanese occupation of northern China. The worker suspected it was important, but he didn't want to report it to the Japanese, so he hid it in a well. And then after World War II, he was worried that if it was revealed, the skull was revealed, he would have to admit that he helped the Japanese. So there it stayed, apparently, in the well for 85 years, until 2018, when as a much older man, he donated it to science. Now, I have no idea if that story is true at all. I find it hard to get any information about it, even the name of the person who donated it, I cannot find. Regardless though, it's certainly authentic, and it added fuel to a pretty intense debate on where Chinese fossils fit in human evolution, which has just been brought to everyone's attention again, international attention again, by the successful sequencing of DNA from the Harbin cranium. Or, well, kind of, you'll see. Not quite the cranium. For all the attention this Dragon Man gets, it's far from the only puzzling fossil from China. It's not even the biggest one, despite how robust it looks. There are actually two, quite significantly larger. Today, we're going to tell the story of human evolution from the perspective of these fossils. What do we know about Dragon Man? Who are these larger fossils? Are they Denisovans? And was there even a population of Neanderthals hiding right under our noses since 1958? Guys, are you planning on visiting China to find ancient lost lineages of humanity? If so, you simply have to download Saily, the sponsor of this video. Saily helps you avoid crazy roaming charges and keeps you safe whilst traveling. Saily provides these things called eSIMs. They're basically a digital SIM card for your phone so that you can continue to use it whilst you're traveling abroad. You don't have to buy a SIM card whilst you're traveling, which is always a bit dodgy. You can get the SIM ahead of time. It's really super convenient. All you have to do is download the app and then you just pick your country. Look at this, China from $4.49. And they even have regional plans if you're not staying in one place. Super affordable, very affordable. We've all been stuck outside a train station because we're trying to just use the Wi-Fi. All of that is a thing of the past. It's just the best and most affordable way to stay safe and stay connected whilst you're traveling. It's just the future of using your phone whilst abroad. Get an exclusive 15% discount on Saily plans. Use code StefanMilo at checkout or go to saily.com/StefanMilo. Download the app. If you're getting abroad, download the app. Give it a look. Before we get to Dragon Man, there was one thing I really wanted to know first. How long have hominins been living in East Asia?
You know, it's a bit of a debate, you know, and most of these areas and most of these questions that we're going to be talking about today are a matter of debate. But right now, it looks like the earliest hominid appearance is about 2.43 million years ago.
That's Professor Christopher Bay, Professor of Anthropology at the University of Hawaii at Manoa.
I actually specialize in paleoanthropology of Asia, and I work a lot in Korea, China, and Japan. I've spent some time as well in Southeast Asia.
He's just written a fantastic book all about human evolution in Southeast Asia. It was a Christmas present to myself. It's a really good book. You'll definitely enjoy it. There's a link in the description. It's the only summary of human evolution from an Asian perspective available to read, really. The really old site he just mentioned, at a whopping 2.43 million years old, is Shihodu in China's northern Shaanxi province on the banks of the Yellow River. A beautiful region steeped in Chinese history. It looks fantastic. I'd truly love to visit. I found the paper discussing Shihodu though. Here it is. Evidence for the earliest human settlement in northern China. What they found, I will be the first to admit, does not look like much. It really doesn't. Very, very simple stone tools. One of the challenges when you go further and further back in time is that our technology, human technology, got simpler and simpler, and it just becomes harder to distinguish from regular rocks, broken rocks. But a lot of it revolves around how many flakes were removed and is there a pattern in their removal. You can see it here in one of the artifacts from the paper. I think this is the clearest example. 6 flakes have been removed along the top. Maybe it's hard for nature to remove flakes in a pattern like that, especially if you have multiple examples at the same site showing some sort of pattern in flake removal. But the evidence doesn't just rely on that one site. There's another one called Shangchen, which dates to around 2.1 million years ago. Again, more stone tools. I will grant you, these rocks, humble rocks, are not very visually striking. And as I said, there is always a debate about whether we're looking at a tool or a rock. But we do have ancient human remains from China too. The oldest remains so far, I believe, are called Lantian Man. He lived an astonishing 1.63 million years ago, and he, or she, was living their best life, killing bison, chopping them up with their stone tools. It's very cool. I'll never get tired of looking in the face of a human well over 1 million years old. It's incredible. That's so staggeringly old. It's fascinating. The fact that these early humans were able to expand as far as China does really say a lot about their intelligence and their adaptability. I mean, how many rivers did they have to cross? Different prey to hunt and to understand. Adjusting to different climates, very different to the African climate we evolved in. They were certainly, Lantian Man was certainly different to us in many, many ways, but I think you can see that first spark of human ingenuity within them. You might recognize yourself in him as they're chopping up something with a pointy rock. You might see yourself in them. These Asian fossils are actually some of the first to ever be discovered by science.
You know, before Africa really, got on everybody's radar due to the major finds in Olduvai Gorge, East Africa, and then in South Africa, it's pretty amazing because Asia was considered to be the cradle of mankind. Eugene Dubois, who actually is credited with finding the first Homo erectus fossil in Southeast Asia, specifically went to Indonesia looking for the quote-unquote missing link. Because he was under the impression from Ernst Haeckel that if you're going to find the missing link, it's going to be someplace in Asia.
Ernst Haeckel was a German zoologist and naturalist, a big advocate of the ideas of Charles Darwin. He was also a fantastic artist. I love these old illustrations of animals. They're absolutely stunning. Here he is looking just so stereotypically Victorian. He also had some very Victorian views about race, but that's probably a story for another time. Unlike Darwin, who believed humans evolved in Africa, Ernst believed that humans evolved on a lost continent called Lemuria, which apparently existed in the Indian Ocean. He didn't invent the idea of Lemuria. It was a way to explain why different fossils and animals appeared so similar in different parts of the world. Obviously now we know that's because of plate tectonics. Those different parts of the world were once connected. But in the 19th century, they did not know that. Ernst Haeckel thought that perhaps Lemuria could have been the continent that humans evolved on. He was wrong about that, but it did inspire an explorer called Eugene Dubois to head out to Southeast Asia and try and find the origins of mankind.
So Eugene Dubois got himself moved. He actually gave up his professorial post and then joined the military and then moved his family out to Indonesia, specifically to look for fossils. And that's the late 1880s and then early 1890s when Homo erectus, Pithecanthropus erectus was first announced, right?
As a result of these discoveries, the end of the 19th century, early 20th century, many anthropologists believed that humans originally evolved in Asia. They kept finding extraordinary fossils like Peking Man outside Beijing and the Sangaran fossils in Indonesia. However, in 1924, Raymond Dart found the tongue child in South Africa, and since then we have only gathered more and more evidence about human origins in Africa.
you started to find fossils like Lucy, and it's really hard to be able to compete with fossils like that.
However, despite all of that, it doesn't mean that Asia didn't play an incredibly important role in human evolution. It's been home to humans for over 2 million years. And this is where these early fossils still cause a big debate, a really big debate in anthropology. All of the ones we've mentioned so far could be described as some form of Homo erectus. I'm sure you recognize the name. Obviously now we are Homo sapiens. But what happened in human evolution in the 2 million years between us? What happened? We have lots of incredible skulls like Kabwe from Zambia, Dragon Man and others in China, all sorts of interesting skulls from Spain too. Anthropologists simply have not been able to agree how to categorize these skulls. Are these one species we're dealing with? Which specimens are we related to? Which ones do we descend from? How do they relate to each other? We just don't know. We quite simply do not know. And this debate is called the muddle in the middle. And the role of these Chinese fossils in that muddle is still not clear. It's still not clear at all.
So from about 300,000 years ago up until about maybe 50 to 100,000 years ago. So that time bracket is what we're really interested in. And in that time bracket in China, there are a number of really important hominid fossils that have been discovered over the past half century.
Obviously, we already mentioned the Harbin fossil, the Dragon Man fossil. But there's another really important cranium from the region.
One of the best known is a fossil called Dali, and this is found in northern China. Dates to between 200,000 and 300,000 years ago. Fairly intact skull.
Dali was found in 1978, just the other side of the river from that really old Shihodu site mentioned earlier. Another absolutely stunning fossil was found in Jinyushan, close to the border with North Korea. Are these related to each other? I really wanted to ask Christopher about that.
We actually had a meeting of the minds, so to speak, right? And so we met in the Institute of Vertebrate Paleontology and Paleoanthropology in Beijing. And so my Chinese colleagues and I had basically a 2-day meeting to talk about the degree of variation in the hominid fossils in China. And so we got together and we said, you know what, let's talk about this and see if we, are there grounds to just simply group everything, lump them all into one group, or are there enough grounds now to actually separate them out into distinct groupings, right? And there was a unanimous agreement that they said that, you know what, Homo longi looks good, and it's named after the Harbin skull, and the Dali fossil and the Jinyushan fossil should be assigned to Homo longi.
According to Christopher and his colleagues, these three fossils have enough in common that they deserve to be all put under the same label, Homo longi, after the province of Heilongjiang. Although that's not to say there aren't differences between them, Harbin is certainly bigger than Dali. I just can't get enough of their really robust brow ridges these people have, more so than even a Neanderthal, combined with their low skulls, those really long flat skulls. It just looks prehistoric. I know, I don't want to insult them, but it just looks prehistoric. It's incredible to see. Their eyes are just so big. Can we untangle that muddle in the middle though? Can we untangle that? Can we say where they fit in our evolutionary tree? It's very, very tricky, but that is kind of where that new study on their DNA comes in. The proteome of the late Middle Pleistocene Harbin individual. Bit of a mouthful, but this is one of 2 very important papers that just came out, studying the DNA and also, as you could tell there, the proteins of Dragon Man. It's been all over the news. I'm sure 90% of you are watching this video because it's been in the news. But basically, your proteins within you can be studied and analyzed in a similar way to DNA. The advantage of studying proteins is that they survive much better. So there are many, many times when DNA is just not preserved, but often in those situations, we can get proteins. Even I think I read that proteins can survive up to 2 million years, even in tropical environments. So this is really going to be a key technology in the future when it comes to unraveling human evolution. The disadvantage is that it just doesn't contain as much information as your DNA. No way around it. It's painting with a broader brush, but you can still see relationships between different fossils. In 2019, this jawbone found at Baishia Karst Cave, right in the Tibetan Plateau, was identified as Denisovan through proteins. And from the top of the plateau to the bottom of the sea, this jawbone was dredged up from the Taiwan Strait. And again, thanks to proteins, identified as Denisovan. And now, finally, the Harbin cranium too. According to this study, the Harbin cranium groups in with Denisovans, the early Denisovans found at Denisova Cave. This second paper is also incredible. Until this year, all attempts to get DNA from the Harbin cranium had failed. They had tried to get genetic material from there, but it just came up blank every time. However, Fu, the leader of the protein paper, had been working with another team to get DNA from here. That circle is not actually highlighting the tooth. It's highlighting the plaque, the dental calculus, the gross stuff stuck to the teeth. It turns out that the plaque can act as a kind of time capsule, protecting DNA inside it, presumably from the saliva of the individual. At least in the case of Harbin, it's protected the DNA in there for 140,000 years. So if you take anything away from this video, do not brush your teeth. Don't brush your teeth. You're really hindering scientific research in 150,000 years. Geneticists are going to need that. The mitochondrial DNA gathered from the plaque also placed the Harbin cranium in the Denisova family, particularly the early Denisovans, which makes sense because Harbin is an older cranium too. It's an older fossil too. It's around that age. It's so cool to finally be able to look these Denisovans in the face instead of just thumbs and teeth and just small fragments of bone that, I don't know, you just can't relate to them like a face. When you see someone's face, you get a true sense of how they looked and who they are. It's brilliant. I love it. Presumably, this also means that the Dali cranium and the Jinyu Shan are also a part of this Denisovan population. Very cool. Here's where things get interesting though. A little bit complicated. Proteins, as I said, paint with a broad brush, and mitochondrial DNA only can tell you the history of your maternal line. So there's still definitely a lot we don't know about the populations that this Harbin cranium belonged to, that the dragon man belonged to. And one of the things that's still debated is the relationship of dragon man to these larger craniums I mentioned at the start. These come from two different sites, Shujiao and Shuchang.
And you've got Xuchang, which is another major fossil site, hominid fossil site from central China, which is actually located not too far south of Shujiao. And so Shujiao, it's interesting because it was known since the 1970s, and they have the remains of more than 11 individuals of hominids.
Unfortunately, the remains at Shujiao are very fragmentary. But based on reconstructions, they had some serious noggins.
So they matched the parietal fragments with the occipital, and they were able to actually reconstruct the posterior part, the back part of the skull, and then from there, they were able to reconstruct the estimated cranial capacity. And they realized that the cranial capacity for Shujiao is actually quite large. And very, very similar to the cranial capacity that was estimated for Xuchang. And we're talking about 17 to 1800 cubic centimeters. And the average modern human cranial capacity is about 1350 cubic centimeters, right? Neanderthals are like 1400 to 1450. So these guys are actually quite large.
Even the dragon man cranium, that robust cranium, had a capacity of 1420 cc's. So Shujiao and Xuchang, they're much bigger on average. You could find modern humans with heads that big now, but it's definitely not average to have a big head like that now. Professor Bei and his colleague Shiju Wu feel that Xuchang and Shujiao are not quite the same population as Homo longi. They gave them a different name, Homo juluensis. Where does the name Homo juluensis comes from?
So this is also kind of funny because we could have named it after Shujiao, which is the type specimen, right? But we realized that if we said that this should be called Homo Shujiaoensis, no one outside of China is going to be able to pronounce it.
Yeah.
So we said, a lot of people won't be able to pronounce Shujayao, right? Let alone Shujayaoensis. So we said, let's come up with something that's really easy to remember and that will stick with people. So Julu actually literally means big head because the cranial capacity is between 1700 and 1800 cubic centimeters.
Just like a tiny pocket of like prehistoric NBA players in China.
Yeah. Yao Ming's running around northern China.
Right?
Yeah.
Probably not giants walking around. I know that is sort of a conspiracy, pseudo-archaeological conspiracy that some people have, that Denisovans are giants. I don't really know where that started from. Shujayao is full of the remains of broken and butchered horses. I love to imagine them out there on the plain, listening to them plan an ambush, celebrating perhaps the prospect of a full belly. Did they recount the actions of the day, argue over who gets what part? I love imagining life deep in prehistory. It's the best. Here's where things get complicated even more. I know I've said that before, but this video gets complicated. Professor Bay and his colleagues believe that Homo juluensis is also a great match for the Denisovans, and it comes down to the morphology of two specific teeth.
One of the reasons is if you actually look at like the tooth occlusal surfaces, right? So the skull, the teeth morphology, they look almost identical between Shujayao and Denisova, right? So you could change them and be basically the same individual, right? And so it was a pretty easy argument to make at that point to say that the Denisovan fossils should be assigned to Homo juluensis.
I had to ask him what he thought about, Homo longi now being assigned to Denisovans, or rather Denisovans assigned to Homo longi based on genetics and proteins. But based on morphology, he thought it was this Homo juluensis population. I had to ask him about that. Do you feel like there's a sort of tension at the minute, not just in paleoanthropology, but in all of biology, between sort of genetics and the morphology and behavior of creatures? Because the example I always think of is grizzly bears and polar bears interbreed in the wild.
Yeah.
And yet to observe them, they have totally different behaviors. They look totally differently. From our perspective, they're obviously two different species, and yet on a genetics level, they can interbreed and have fertile offspring and all of that. Do you feel like there's this tension between those two sources of evidence at the minute?
Yeah, I totally agree with that. I would say that Homo longi and Homo juluensis would have been able to interbreed with fairly regularly without too many problems. They were completely different. They're different populations, but they probably interacted at some degree, so at some level. So they probably would have been able to interbreed. And so if we get protein data from Shujayao and or Shuchang, what they're going to find is that the three groups are probably very closely related. So it'll be very, very interesting to see. And to get back to your original question, though, about whether there's some tension between what the geneticists are saying, what the morphologists are saying, we need to remember that Denisova was originally proposed as a new species based on the DNA, right? And it wasn't accepted, right? And so because at the time, the field's kind of conservative. And so we weren't, and it's more dominated at the time by morphologists. And so, the morphologists weren't ready to accept a new species based off of the DNA. So I think that there is some tension, but what I think will happen eventually and where we're going is, right now it looks like, you've got the protein data that's saying that the Denisovans can be assigned to longi, right? But we don't have any protein data from Shujayao. So it'll be interesting to see if we have protein data from Shujayao that suddenly it shifts towards Shujayao, because then you already have the morphology saying that Denisova and Shujayao overlap.
Yeah, I can't remember who said it, but someone, no doubt very intelligent, said nature doesn't draw a line without smudging it. And there's like, it's like we're trying to, for our own understanding, create organized labels for these specimens in our evolution, but really there's no hard lines in evolution, right? It's all just...
It's all blurry. it's very, very true. But at the same time, we do need to have some names out there that help us organize the information, right? Because otherwise, if everything is blurry in this fuzzy gray area, it's very difficult to be able to talk about be able to answer any major questions related to evolution.
Whatever name we give these fossils, their similarities and differences are probably evidence of this ebb and flow of human evolution. Large periods of time, isolated, punctuated by moments of admixture and coming together. Perhaps in the same way that we know modern humans and Neanderthals admixed several times over the course of a few 100,000 years, but we still looked really physically distinct, really physically different. Who knows, perhaps Shujayao and Dragon Man were admixing with populations we haven't even found yet.
Both of them are probably, have some ancestral roots with Homo erectus that was indigenous in the region, but you've got pretty good evidence of continuous dispersals coming out of Africa and across Eurasia into places like China. So that's where the interbreeding goes on and where the variation comes from. So whether Longy was a distinct, eventually a distinct evolutionary dead end, or Juliensis was a evolutionary dead end, it's really too early to say right now at this point.
Regardless of where this debate ends up, it really shows the diversity of this Denisovan group. They lived as far north as Siberia and Harbin in China, really far north, cold environments, down to the high altitude of the Tibetan Plateau, to the Taiwan Straits, down even as far south as Laos. They really were spread across a wide area of Southeast Asia. And maybe even as far south as island Southeast Asia, if you saw my video on the Denisovans in Papua New Guinea. And yet, they may not have been alone. All of the fossils we've discussed so far have been really sort of centered around northern China. But far to the south, just a little bit outside of Hong Kong, there's one that was found in this place called Lion Rock. It's actually the smaller of these two hills that you can see on screen. It's been called Maba Man after the village next to that rock.
Maba is another site where it's has a fairly intact skull cap that was found in Guangdong in southeastern China. And it's interesting because when Maba was first found in the 1950s, they said that this skull actually looks like a Neanderthal. And if you found this skull in Europe, you would just call it a Neanderthal. But because it was found in Guangdong in southeastern China, and we knew at that time in the 1950s that Neanderthals were only known at that time from Europe and from the Levant, the Middle East. So they said it's impossible to have a Neanderthal in southeastern China at that time. And so it kind of died.
Now we know that Neanderthals made it as far as Denisova Cave in Siberia, which is really far east to what we thought was their homeland of Europe and the Levant. And it's really, really, really far east. Denisova Cave is actually as close to this Maba specimen as it is to any specimen ever found in Europe. Can we really be sure that Maba isn't a Neanderthal all the way down on the South Pacific?
But one of the things, though, it's interesting because, in the 1950s when Maba was originally found, and the suggestion was that the Maba fossil represents a Neanderthal, and it was discounted because Neanderthals were only known from Europe and the Levant at that time. But now we know that Neanderthals are as far east as southern Siberia, right? They were found in Denisova. So it may be possible that, a small group of Neanderthals, eventually moved down into southeastern China, and then they just died out, right? In the span of a couple generations, you're not going to see that much morphological variation. So it could have been a group of Neanderthals coming either from the Levant or coming from Siberia and then moving down into southeastern China. So, what this says nowadays is we need to be more open-minded about the idea that Neanderthals may have actually seen the Pacific Ocean. It's one of the.
I don't think that's a crazy thing to say at all. I don't know why, but the thought of a Neanderthal dipping their toes in the Pacific Ocean, it really brings them alive again to me a little bit. It's almost like they've been taken from this hypothetical space in my mind and dropped back in the real world. I don't know. I love it. I love it. Turning the imagination flowing. Whatever imagination does, it gets it doing it. Whoever Mabaman was, it seems he came to an untimely end as evidenced by these pretty large depressions in their skull. So it didn't work out great for him or her. But it really goes to show just how complicated this period of human evolution was. Just in China, never mind untangling the rest of the muddle in the middle across the whole world. You know, Homo longi is a Denisovan, but how they're related to their even bigger-headed cousins, Homo juluensis, up for debate. We need DNA and proteins from them too. Meanwhile, Neanderthals may have been paddling and fishing and gathering mollusks on the shores of Hong Kong. Fascinating, man. Fascinating. What a fascinating time to be studying human evolution. Who knows what we will be debating in 20 years' time, 50 years' time. It's very cool. Very, very cool. Whoa, look at that. I'm in the Pacific Ocean, just like a Neanderthal. Not in Hong Kong, though, obviously. I'm on the other side. Thank you so much for watching. Thank you so much to Professor Christopher Bay for his insights. His book, The Paleoanthropology of Eastern Asia, is a certified banger. Do check it out in the description down below. I really enjoyed reading it, and it inspired this whole video. Thank you to Ettore Master for the artwork, Michael for editing, and for you guys for watching, and all my patrons for supporting everything I do. Woo, so cold. Subscribe for more videos on ancient history, super ancient history.